out of here towards the end of the day yesterday. We had a couple of minutes, and we kind of had to stop what we were doing and take a look at 7 and 8, because all of a sudden everybody had the exact same brain part.
What?
I know, stinky.
What?
Now, what was happening on that one was that we forgot what it meant. We had been doing so many problems in a row of angle bisecting. And once you guys get going on the same problem over and over again, you think that the next problem is the same thing, as opposed to going back and rereading and seeing the information that's given to you. Happens all the time. It's not uncommon for students to do that, no matter what class it is. You just think, oh, go on. Well, yeah, you do the head bob and the dance and everything. Now, my suggestion on 7, I think we talked about this in class. I think I stopped and I drew it up there, didn't I? Pretty sure I did. Is that if you look at number 7, 7 is talking about angle AOB, BOC, and AOC. Does it talk about anything in relation to the ray OD? No. It had nothing to do, number 7 had nothing to do with that ray. Same deal with number 8. Number 8 had nothing to do with the ray OA. Just had those two angles to worry about. So the suggestion that I gave you guys was to just disregard the diagram as it was drawn to begin with and redraw them separately. Because if you see it separately, blown up a little bit, math is easier to math. Yes, ma'am? Absolutely not. I'm joking with you. You don't have to ask for it, but I appreciate it. I'm just asking. No, it's not a disruption. I'm very hard to bother. I'll bother you. Wow. I feel much better.
I guess it was
What's 14? That's fine.
So I already set up 7. Let's look at 8.
Stop. You have to shoe him. Okay.
All right.
Let's pass it.
D, O, C, and B. All right. So D, O, C, and B. B. Okay. All I'm doing is I'm redrawing the diagram bigger so you can see it easier, and we can now figure out what it's asking us to do. First one tells you it's 8x plus 13. Next one has us at 3x minus 10. And it tells me something about the entire setup. Anywhere in this problem to start out with, did it talk about the two smaller angles being equal to each other? The answer is no. So, I do know that I have two smaller angles that can be put together to create not a vertical one, but a larger angle. When you have two small angles add together to get a larger angle, what do you use? That's all it is. We just use angle addition. The two smaller ones add up to the larger. Put that together, we're going to get 3x minus 10 plus 8x plus 13 is 12x minus 6. Okay. From here, we just set it up. We can go on. Combine your like terms. What's 8 and 3? 11. So we have 11x, negative 10, positive 13. Okay. Variables on both sides of the equation. Think I'm a little guy. Not that I condone bullying, but I'm going to bully the heck out of this. I know. I wasn't bullying you. You're paying for this, Phil. I tried to pick it up. Jeez.
Okay. Who likes bullying? I don't. Yeah, I did it right.
Good. Now, what I've seen a couple of people do is when they move the 6, how do you move a negative? You add it. So what's 3 plus 6?
9.
X is 9. I had some people accidentally subtract the 6 because they brain farted, so it's not brain.
Brain farting. I don't think brains can fart.
I've been teaching for a while. Brains can surely fart. Did it ask to solve? I think it was just solve for x, wasn't it? Oh, then find the angle measure. So solve for x, we got 9. 8 times 9 plus 13. 3 times 7. I said 7, didn't I? I meant 3 times 9. Yes, and I was, then you subtract 10. I did, I just brain farted.
Yeah, your brain did not fart because it doesn't.
My hair grew a little bit right there.
Yeah, that is bad.
It's already been like a long day. And then lastly, I do feel bad for you guys because this is the third class of geometry. It's the third time I've done most of these problems, so it's kind of like, okay, I know what the answer is because I just did it, and I'm gonna screw something up. So I'm sorry. 85 and 17 is what? 102.
Yep.
So let's check and see. 12 times 9 is 108. Subtract 6, we get 102. Yay! We need math. All right. Yes. All right. After that, 9 and 10 did not have diagrams, did they? They didn't. But what do vertical angles look like? Like an X. Okay. So if you know you have a vertical angle, if you know you have vertical angles and it tells you what the labels are, it says that angles blah blah blah. A, B, C, and E, B, F. If you know that it's a crossing part like that, and you know that's what the diagram looks like, draw it. Because now you know that since they are vertical angles, because it told you they are, they're either going to be across from each other going one way or the other, but no matter what, when they're across from each other, they're always going to be equal. Because that's the definition. Notice, guys, just like we discussed, most of these problems start with vocabulary via geometry that goes to the algebra to set it up. All right? So you know that these two have to be the same, so we have, what, 3x plus 8 and 2x plus 48. Put it together, we get 3x. Now, I've had other kids ask me, do I have to draw a picture for this because I know what vertical angles mean. I know that they have to be equal. No, if you understand that it tells you they're vertical angles, and you know, okay, ding, 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 they have to be equal, just write it down, and that's fine. Or if you couldn't remember what that setup was, but you knew what it looked like, then you fill it out. You're not dumb. You had a brain fart. Your hair just grew.
No.
Are you saying that he's dumb?
I'm saying, no, he probably smart. That's probably the only thing he.
I think he's probably air quotes too.
Why'd you skip the letter D?
B?
A, B, C.
Because B was here.
No, A, B, C, D, F. That makes me laugh.
I'm sorry.
He's so sad.
I'm sad. I don't like that.
Variables on both sides. What are you going to move? Pick on the little guy. Move the 2x over. We get x plus 8 is 48. What's x? Okay. Now, it didn't ask you just to solve for x. It asked you to solve for the angle measures, which means what do you have to do? Substitute back in. Very good. You listen. 120 plus 8 is 128. I hope so. 80 plus 48 is. There you go. Okay.
That's really good.
Just clear your brain. Get rid of all that other stuff you learned so far today. You don't need it.
Probably won't.
Don't do that.
Touch your cheek.
It's so much easier to say it, right? Complementary. Complementary angles. What do they add up to equal?
90.
90, good. So you are told that you have sets of complementary angles. That means that those two angles added together have to equal 90. So you write it out. And why do we know that it's 90, not 180 when you're looking at complementary versus supplementary? What was the stupid thing for me to tell you guys about that? C comes first. C comes first in the alphabet. Complementary comes before supplementary.
I like my C.
Oh yeah, yours is the one that where it was. It makes the
Complimentary is 90.
Okay. Add them together. Add the 1. What is it? 1, 2, 1, 13, right? Okay. And then you substitute back in, which okay, that's geometry. On the other side, you had two of those questions that talked about the angle bisectors. Remember, we did one of them in class, where all you had to worry about doing was redrawing the diagram, knowing what the bisector does. What does an angle bisector do? Doesn't cut two angles in half, it cuts one angle in half, which makes two congruent angles. Okay? That's what you're looking at being able to do. So what do we have? 18, which one do we have? 18 and 20? All right, let's do 20. So let's see, QS. Overdraw it, because you can. P, Q, R, S. Tick marks. Notice the difference between this one and the one we did on number 7 and 8. Number 7 and 8, you were looking at, you had two smaller chunks that added up to the large. This one doesn't have that information. This one only gives you information about the two parts. It doesn't tell you what the whole thing is. Okay, so in order for us to be able to make this work, is that this case, they have to be equal to each other to make the problem work. Now, you set up against each other, we get what? 2x plus 10.
Gee, my chest hurts.
Take on the little guy, add, subtract 2x. Is it okay if I subtract 2x and add 17 at the same time?
Oh,
I'm not going to screw anybody up too much. All right, write it out. What's x? And then it's a matter of 18 and 10 is 28. Excuse me. 45 minus 17 is also 28. Gives you a whole angle of. Okay. Then I believe the last one on there was number 25, wasn't it? 25 has said you had what type of angle pair? Complementary. So not only are they nice to one another, saying, hey, your shirt's really nice, they also add up to equal how much? And all of a sudden, this problem mirrors the exact same thing as numbers.
which one do you want? I got a whole bunch.
Oh, I don't know. I just can't remember which one it was on the other side. 10. It looks just like number 10 then. Okay.
Hey, why? Why?
Did you want me to finish that one out, or are we okay on that?
We're about.
Now, when we get to the quiz stuff tomorrow, then, what I want you guys to realize what's going to be on there. We've got sections 1.2, 1.3, 1.4, and 1.5. Okay. We have those 4 sections that we're quizzing on tomorrow. Each one of these sections had a little bit of different information to it. When we first looked at 1.2, that was the introduction to labeling, like how to label EL or LE.
Oh,
You're right.
Am I?
You're right.
I was-
You're right. You're correct. You're good.
There's a reason why I taught that.
Yeah. Understandable.
Like points, rays, so what we would look at was, do you remember what collinear meant? Do you remember what coplanar meant? Do you know how to label a ray? Do you know how to label a plane? Do you know how to look at when 2 planes intersect, what do they create? Remember front wall, ceiling, things like that. That was the introduction to a lot of that. From there, we switched to segments. When we dealt with segments, we dealt with a couple of things. We talked about adding them. Where basically it looked like this. Segment addition tells you that you get 2 segments that are collinear, 3 or more points that are collinear. I know I forget what the words are sometimes. As long as they are in the same line segment, we can add them together to make up a larger one. So real fast example, if X, Y, and Z are collinear on the same line, and you know that the first part is 4, the whole segment 17, what's left over?
I don't know.
13, isn't it? All you have to do there is just 4 plus something is 17. You created that quick little numerical equation, but without having too much thinking involved. So you knew how to set that up. But then we switched it and threw variables in there. But did that change anything? No. It's the same thing. Okay. Also in here we talked about, let's bring this back, a midpoint, or sometimes called a segment bisector. What's a midpoint of a segment? The middle point, hence the word midpoint. SMRT, exactly. It is the point at which creates 2 congruent segments within the segment. Okay? The midpoint is the point. A segment bisector could be anything. It could have been another segment, it could have been a ray, it could have been anything like that. Midpoint meant that. 2 congruent segments. That's what midpoint. Those were pretty quick. Again, it's the same idea as an angle bisector, but instead of being on an angle, you are on a segment. The math doesn't change at all. Just the diagram. Excuse me. So let me give you a few of these examples that I want to show you as far as some review junk, and then we'll talk about angles here in a second. This stuff? Yeah. Of course, all right. No, absolutely not. Sorry. What's that? What's on my laptop? Sticker.
Am I?
It's a Pearl Jam sticker.
This is a review.
Yeah, this is some review stuff. You'll have to bear with me. Like I was told last hour, what I have done to this, as I've done. There used to be an old math teacher here named Mr. Vittoni. He retired about 7-8 years ago, and what he would do when he was making worksheets or quizzes or tests and stuff, he would take a whole bunch of other worksheets and tests and quizzes that he's had over the years, and cut them out and just tape them to another sheet of paper and make a copy. It's called demonizing a document. So we do that. I do that a lot because a lot of times what I do with these things is that these worksheets are from my older textbook, and there is better problems than what we had available with the newer textbook, especially the algebra. So I know that's where you guys are struggling right now, so that's why I want to make sure we do a little bit extra work. Okay. Now, on this one here, don't worry about it saying section 1.1, because that was 1.1 for the old text. These style problems were out of 1.2, just so you guys remember. So if I look at number 1 on there about 1 point, it says points H, I, and G are collinear. Well, collinear means they have to be the same line. So you look at the diagram. Are those points on the same line? Yes. There's your answer. Okay. Now, let's skip down to the second number 5 on the sheet. Yes, there's like 3 number 5s.
Yeah.
And I want to look at what it's talking about. It says in diagram, M is the midpoint. So if you have a midpoint, what do you do algebraically? You set them equal to each other. Now, in this one, it said find the indicated length, which means it's going to ask you to find a specific part of that segment. Okay. I get a little bit ahead of it, even though this is a new laptop. It doesn't keep up with my brain.
Dang.
I know, right?
So you're not very.
So we know that we have a midpoint. We know that that means that PM has to equal MQ. So what I do algebraically then to write it out? I get that.
Yeah.
Okay. You pick on the little guy. Boy, that sounds like the same thing over and over. Then, doesn't
Yeah.
it?
It does.
Pete and repeat were in a boat. Pete fell out. Who was left?
I don't know.
Pete and repeat were in a boat. Pete fell out. Who was left?
I don't know.
Who?
Ricky was left on the boat.
What?
Wait, say it
Excuse me?
Say it
Again.
again.
The horse's name was Friday.
You technically wouldn't say
No, he was.
Hey.
All right. It is Pete and repeat are in a boat. Pete fell out. Who was left?
Oh, Pete.
Repeat. Pete and
wait,
repeat were in a
wait,
boat.
wait.
Pete fell out. Who was left?
Repeat.
Pete and repeat were in a boat. Pete fell out. Who was left?
Repeat was on the boat.
Oh
I get
my God!
Oh, it's my
What is going on?
I didn't
I
realize
didn't know you were doing my
Yes.
You making fun of somebody else's stuff?
No, I didn't.
Anyway, back to the math. I promise I will try not to get off task again. I can't even say that without a straight face. What do I do next? Add 17. I guarantee you right now, if one of you guys looks down on your paper and you were getting ahead of yourself, I bet you at least one of you guys got the negative in front of the one.
Yes.
No, seriously, it's a super common mistake, okay?
Yeah, it's irritating.
Make sure you remember if after you move something around, that negative's still there, okay?
Yes.
You get 2 for X, and then I think the diagram asks, substitute back in, 2 times 12 is, back 17.
Joe, come on.
Okay. Segment, bisector, midpoints. Yes, ma'am.
How do you know when to add them together and then to
Knowing if it says it's a midpoint, or if you flip over to the other side. If you flip over to the other side, you'll see the difference in the wording. If you look at number 26. See the difference there? Everybody see that? This is a great question. Look over on the other side, number 26, and look at the difference between that one and the one we just did when we had to deal with the midpoint. Notice how it's written out differently. See how that's written out differently? In this one here, what do we have to do? What do you have to do for this one? Find the total length, okay. But how do you do that?
You put those two in the coordinates.
Perfect. We use segment addition. This one, it doesn't tell you you have the midpoint. It's telling you you've got the whole segment, you've got two other parts. They look like they're in the middle, but do we know for certain that they are? No. You can't assume. Remember, you'll make an angle side side out of you and me. Subtract 3x. And subtract 4. Okay. So what is that? 18 minus 4 is what? 14? Oh. So was it midpoint? Sorry. Somehow got the one without that I did the original time thing, sir. There you go. There you go. All right, that's what we're looking at doing. Now go back to again on that same side. Look at the problem above it. Problem above it talks about collinear points. It's a big picture diagram, isn't it?
It's a T.
Big picture diagrams, you never read the questions until you fill in the diagram. Now, it says that points A, B, C, and D are collinear, which means they are all where? Same line, okay? Then it says C, X, Y, and Z are also collinear, which means they're also on the same line. So the next line says AB, BC, CX, and YZ are all equal to each other, which means they're all congruent. So you can put your tick marks in. Just like that. Okay. It then tells you a segment length of AD. That is 54. It tells you XY, this little chunk here is 22. And it tells you XZ is 33. What is the next thing you're able to figure out just by looking at what you have there? YZ, right. Well, how much is YZ then? 11. Everybody see that? Just by filling things through as you're going around, you get right off the bat 22 plus something has to equal 33, which means that something has to be 11. Which means everywhere else I see this tick mark, it's going to equal how much? 11. Ooh. Now go back here. What's 11 plus 11? Okay, 22 plus what is 54? 30. Now, in the diagram, have you now filled in the blanks for everything? Yes. Then answer your questions. That's how you set up these types of problems. You never read what they're asking you to do first. If you do that, it takes too long. It is so much easier to take the diagram, fill in what you know, what can you show real quick, and then backtrack. You're going to see big picture diagrams a lot. And I just want to keep you guys in the habit of understanding how that stuff works, okay? Segments. Go to 29 real quick. Right below it. What is that problem missing? A diagram. Okay? Missing a diagram, which means what should you do? Okay? I believe it said that J is between H and K on segment HK, correct? Well, that means the segment that you have is H and K. Does it tell you where to put point J? It just tells you that it's where? Somewhere on the line. It's collinear. It's between them. Does it say that? That's okay. I just put it in there. Now it says that hj is x over 4. That means it's x divided by 4. That also means it's 1/4 times x. What's another way of writing 1/4 as a decimal? 5. The reason why I say that is that sometimes it's easier with calculators to use a decimal. Because here you've got 0.25x. This side you have 3x minus 4. And you know that the whole thing has to equal 22. So as you go to combine your like terms then, what's 0.25 plus 3? Yeah, 3 1/4. It's just a little bit quicker to type in your calculator. I just wanted to show you that because I don't think we've had an example that had a fraction and or a decimal where it was put part of the value. The math is easy from there. It's just a two-step equation. Hey, look at that. Huh. Algebra. Who would have thunk it? Now, that kind of goes through all the different types of segment problems that are on here. What haven't we discussed? Angles. Go back to the other side real quick. Go back and look at the front side. The front side, you have two types of angles. Numbers 10 and 11 versus 16, 17, and 18. Numbers 10 and 11 tell you that you have specific large angle measurements. Whereas on the last three, it says it's a bisector. What's the difference via the algebra? What's going to be the difference? How do you set up number 11 versus setting up number 18? Correct. These here, since you have two smaller angles and the whole, they have to add up to equal the whole. Down here, you don't have that. You have a bisector. You know that these two parts have to be equal to each other. Okay? So we'll take a look at 11. I look at 11. It tells me the entire angle is 135. It doesn't tell me that those two parts are equal. I have no idea. What I do know is that I can add those two together and get 135. So 3x plus 1, 2x minus 6. Excuse me. Let's see, 5x minus 5 is 135. Add 5. And divide it out. Let's see, what is that? 28? Did it say solve for x or solve for an angle? An angle. So I have to go back and substitute in for QSR and substitute it. Okay. That's the difference between what an angle addition problem is versus when we go back to the other one down at like 18. And I know I'm kind of zipping through here. I'm trying to show as many examples as I can with you guys, at least get it started for you. If I go back there, I know then these two have to be what in relation for the algebra? Equal. Because it says it's a bisector. Bisectors cut an angle in half. Each chunk is going to be the same value, so therefore they have to be equal. So you're going to get that 8x minus 16 is 4x plus 20. Back to variables on both sides. What do? Subtract my 4x over to the left. I get 4x minus the 16 is 20. Add that over. Weird to write on this side. Trying to save you guys from not staring at my back the whole time. And then again, it will ask you to find a specific part. I think I might have accidentally cut it out, but that's the idea. Then lastly, go back to the other side real fast at the very top of the page. We didn't talk about those, but those at the very top of the page look a whole heck of a lot like the problems we did a couple days ago. Whether they were going to be complementary or linear pairs. Remember, linear pairs, we draw them out where angle 1 plus angle 2 equals form a line. If you look at the very bottom of that page, the very bottom of that page is where we have the algebra where you had to do 2 steps. Solve for one of the variables first and then substitute to get to the other one, where you set up 2 equations. Wasn't very difficult, but you just had to make a decision as far as which one do you solve for first. Here you have x and y. Which variable is it forcing you to solve for first? X. Now remember, when we had these types of setups, we had 2 scenarios. They were either linear pairs or they were vertical. What scenario is this? They're linear pairs because they're next to each other forming a line. Which means what do they have to add up to equal? 180. Good. Okay. And you go from there. When you figure out that value of x, remember we always would go to the vertical and set those 2 equal to each other. By all means, ladies and gentlemen, I want you to finish the rest of the problems that are on here. I'm pretty sure I've gotten you at least half of them started, okay? The other parts that are in each of those sections are going to mirror the notes and the stuff that we just did. If you can't find it, I went too fast over a problem, pull the video up, rewatch it, and see if it's there. You might even hear a repeat joke. And you can put it on repeat. If you guys got questions and stuff like that, by all means, if you want to grab Flex Pass, we still have some Flex Passes around. Otherwise, if you get through this and you get stuck on something, you got to see how to do it, stop by in the morning. I'll be here in the morning. I'll be more than happy to answer your question before class. All right. I will collect this sheet, this review sheet tomorrow. That'll be due tomorrow when you come in. We'll take the quiz. Quiz, like I said, is about 9-10 questions or so. It shouldn't be more than 25-30 minutes tops. I always make sure we have plenty of time to take any assessment. Therefore, you can always go back and check your work. Okay? There should never be a time crunch on something. If there's a time crunch, that means we weren't prepared or I've made things way too difficult, which means you weren't prepared. Okay. What's that? I've done a lot of preparing for this one. We've spent way too much time in this section. Yes, ma'am. Yes. Yep. Yes, ma'am. What do you got? Let me stop this real quick so I can get there.
What time do we get?
The bell rings.